Hello everyone, welcome to Pepcoding. In this video, we will look at the question smallest range covering elements from K list. Okay, so in this question, you're given K list, right? You're given K list, and in every list, there are some elements. Okay, now you have to find a range. You have to find a range that includes at least one character or at least one number from every list. Okay, so let's take the range of, let's say, 0 to 6. Let's say I have the range of 0 to 6. Now, this range of 0 to 6 is a valid range. Why? Because it includes at least one character, at least one number from these K lists, right? So I have 4, I have 0, I have 5, right? All of these numbers lie in this range, right? This is inclusive. So all of these numbers lie in this range. So that's why this is a valid range. Okay. But what is the size of this range? How many elements can be fitted into this range? I can say that the elements are, total elements are I minus low plus 1, right? Which is 6 minus 0 plus 1, that gives me 7, right? Also, let's take the range of 0 to 5 now. Okay, let's take the range of 0 to 5. Now, in the range of 0 to 5, you can still get all the elements, right? 4, 0, and 5. All of these are included in this range. So, at least one element from every single uh, K list is included in this range, right? At least one number. Here we have 4, 0, and 5. All three of them are included in this range. That's why this is a valid range as well. But now, the size of this range is 6, right? This is a smaller range than this range, right? So I will prefer this answer over this one. Okay, this is my preferred answer now. Now let's take the range of 20 to 24. Okay, let's take this range now. Now in this range, there are 24, 20, and 22, right? Three numbers lie in this range. So this is also a valid range because at least one number from every K list lies in this range. That's why this is a valid range. But what is the size of this range? It is 24 minus 20 plus 1, which is 5. So this is the smallest range that I can get from this nums, right? This is the smallest range that I can get from this sample input. So I have to return. So I have to return this 5 or this range, which is 20 to 24. Okay. So how are we going to solve this question? I hope the question statement is clear. That we have k number of lists, and we have to find a range, right, which includes at least one element or at least one number from every single list, and that range has to be the smallest range, okay, or the smallest possible range. Now how are we going to solve this question? Okay, so let's see. First, we are going to make a claim, right? And my claim is going to be that my answer will include every element or the range, right? I have this range, let's say x comma y. So x comma y, my answer will include the elements from the list only, right? The answer will include elements from the list only. So these x and y, this x and y will be the elements of these lists only, right? I can have 19 and 25, right? I can have 19 and 25 as my range. This is a valid range, but 19 does not lie in this 19 does not lie in any of the list, and 25 as well does not lie in any of the list. Okay, so this is not a valid, we are not going to use this list because this is not going to give me the smallest possible answer. If I take 20 and 24, right, this is going to give me the smallest possible answer because 20 and 24 both are included in my list. Okay, so I'm going to make a claim that answer will include elements from the list only. Okay, so this is going to be my claim, and I'm going to use this claim uh, as my approach. Okay, so let's see what the approach is going to be. Let's discuss the approach. Okay, so in this question, I'm going to use a priority queue. Okay, let's make a priority queue. Okay, and we have a min priority queue. Okay, we are going to use a min priority queue, right? And we will also have a number line. So let's also make a number line. Okay, this and my answer, I will have an answer range, right? This answer range, which will vary from minus 10 to the power 5 to 10 to the power 5, right? This is my constraint given in the question, that my answer range is varying from minus negative 10 to the power 5 to positive 10 to the power 5, right? So now I have a number line, and this number line will be between 0 and the minimum element in this A, right? The minimum element in this list and the maximum element in this list. So this will be 0 and 30. Right? The minimum element in these lists is 0 and the maximum element is 30. Right? So 0 and 30. Now Now I have this range, I have this answer. Now I will also take a maximum. Right. First, we are doing the what, how, and why. Right. We are doing this approach. First, we'll discuss what are we doing and how we are doing it. Right. Then we will discuss why we are actually doing it. Right. And this will be clear as we actually see the dry run as it is happening. Okay. As we parse this answer, as we parse this question, we are going to see why this is actually happening. Okay, so let's take a maximum variable. Okay, so what is this max going to be? Let's see. First, let's call this a red list. Let's call this list this is the red list, this is the blue list, and this is the green list. Okay, so I will take the first element from here, first element from here, the first element from here, and I will put them in this min priority queue, right? In this min priority queue. So I will have 4, 0, and 5. And since this is a min priority queue, the minimum value here will be 0. And the maximum will become 5 here. Maximum will start from 5. Okay. I will have only k elements in my priority queue, right? And this is of min type. Why only k elements? Why are we taking the size of my priority queue as k? Because I only have to check this for at least one element from every single list, right? So I'm going to take at least one element from every single list. That's why there are k number of lists, right? So my priority queue is going to be of k size. So now I have taken the first indexes. I have 4, 0, and 5, right? Minimum is 0. It is sitting at the top. Now I have the maximum as 5 and the minimum as 0, right? So I'm going to take this 0 out. I'm going to take this 0 out, take this 0 out, right? And I will take the range from 0 to 5. And since this range is better than this range, right? This range is better than this range. So I will update this range with my 0 to 5 range. Okay. What did we do? First, we took the minimum element. We took the minimum element from my priority queue and we popped it, right? We popped the minimum element and we checked the minimum element with the maximum element. What the range it is giving me, right? It is giving me a range of only 6 elements, while this range is off from 0 from minus 10 to the power 5 to 10 to the power 5, right? So this is a much better range. So I will update this range with 0 to 5, right? And on my number line, let's say this is my number line, I have 10, 20 here, right? And 5 here, and 15, let's say 25, right? So I have this number line, and on this number line, now the range that I have is from 0 to 5, right? This is my current range. So I've taken 4, 0 and 5, right? I took the minimum element out, I compared it with the maximum element, then I checked if the range it is giving me is better than the range which is present in my answer. If it is present, then I'm going to remove that, I'm going to change that range from my minimum to my maximum of the current element. Okay, so now since 0 was popped, now 9 will be pushed into the priority queue, right? Since 9 is pushed into the priority queue, it becomes the new max, right? The new max is 9. The maximum element at this moment is 9, right? So I will push 9 here, max will update, and the min priority queue will have 4 as its minimum value, right? Now we have 4, and now we are going to take this 4 out, right? We are going to take this 4 out. So if we take this 4 out, we get the range from 4 to 9, right? And the range from 4 to 9, how many elements are in the range of 4 to 9? The elements in the range are 9 minus 4, right? 9 minus 4, we have 4 here, and we have 9 here. 9 minus 4, which gives me 5, plus 1, which is 6. It's the same as this range, right? So I'm not really going to update this range. I'm not really going to update this range because it is not a better range. Okay. So my this range will stay as it is. Now I popped 4, right? I popped 4. So now I'm going to go to 10. I'll push 10, right? I'll push 10, update the maximum as 10 because it is greater than 9, and put the minimum value in my priority queue is going to change to 5, right? If you don't really understand what is actually happening, don't worry. As we go along, you will get the hang of it, okay? So we have minimum element as 5, right? This is my minimum element 5. Now I'll take the minimum element, I'll compare it with my maximum element. So I'll pop the minimum element out, right? Compare it with my maximum. The maximum here is 10. So I'll take the range from 10 to 5, 5 to 10, right? And the range from 5 to 10 gives me 6 elements, right? 10 minus 5 is 5, plus 1, 6. This is still not better than this range. So I will not update this range as well. Okay. So I'm only going to change my answer if I get a range which is better than this answer. Okay. And how am I taking the range? I'm calculating the range as the minimum element from this priority queue and the maximum element that I've kept a score of. Okay. So since I removed 5, I'll push this element which is 18 into my priority queue. So I will push 18, right? The new maximum will become 18 and my minimum will be 9 now, right? So let's take this 9. Let's pop this 9. If we take this 9 and we compare it with our maximum, which is 18, right? I will get 18 minus 9, which is 9 plus 1, 10 elements, right? 10 is not better than my answer. 10 is not better than my answer. Answer is currently at 6 elements, right? So 10 is not better than my answer, so I'm not going to change this answer. So this 9 will be popped as well, right? This 9 will be popped as well. And since this 9 was done, I'll move to 12, right? So we are done with 4, 9, also 18, right? Let's say 18 is here. And okay, right? So we are at 12 now. Now for 12, I have, let's push this into my priority queue, right? 12, and the maximum is still 18, right? Maximum is still 18, but because it is not greater than 18, right? 12 is not greater than 18. So I'll push this 12 into my priority queue. Then at the minimum, I have 10, right? So now I'll pop this 10. Pop this 10 and compare it with my maximum. The maximum is 18, right? So my new range is from 10 to 18. From 10 to 18, I have 18 minus 10, which gives me 8 plus 1, 9 elements, right? At total, I have 9 elements. 9 is still not better than 6. So I'm not going to update my range, right? So this 12, I was at this 12, right? Then I did the work for 10. So I'm going to pop this 10. I did, now I'm at 15. I'll push this 15. 15 will go here. The minimum will be 12. Okay, now I'm at 12. For 12, I will check again, right? I'll pop this 12. I'll pop this 12, compare it with 18, right? The maximum value. Now, for this 12, I get uh, the range of 18 minus 12, which is 6, right? 6 plus 1, which is 7, right? So my answer is going to be 7. Now 7 is not better than my current answer, so I'm not going to update my current answer, right? So I did the work for 12, right? So 12 is going to go here and I will push 20. Now my current max will become 20 and I will push 20 here. Okay, so what is my minimum? My current minimum is 15, right? So I'll pop this 15. I'll pop this 15 and I'll take the maximum, which is 20, right? This is my current range. So I have from 15 to 20. This is 20 minus 15, right? Which gives me 5 plus 1, which is 6. 6 is still not better than my current answer because it is same. It does not really matter. So I'm not going to update the old answer. I'm just going to keep it same, right? So I did the work for 15, right? So this is going to move to 24. I have 24 here. The minimum element is still 18, right? I have 18. Now for 18, I'm going to check again. For 18, I'm going to check again with my maximum element, which is now 24. Right, as I push 24, the maximum element was 24. So 24 is my current maximum. Check again. I get if I push, I check again. I get 24 minus 18. Right, this gives me 4 minus 1, 6 plus 1, 6 plus 1, which is 7. Right, 7 is still not better than my answer. I'll not update this. Right, so I pushed 8. I popped 18. I'm going to pop this 18. Right, this 18 was popped. I'm at 22. I'll push 22. The minimum is 20. Right, the maximum is still 24. Now the minimum is 20 and the maximum is 24. Right, now I have now I have a range which is 24 minus 20 plus 1, which is 5. So this is better than my new answer. This is better than my old answer. So I'll update the range. I'll update the range as 20 and 24. Okay, I'll update the range. Now I popped 20, right? I popped 20. So I'm again going to check, right? This 20 is now popped. Since I have completed at least one of the list, that means that I've traversed through the whole array, or I've traversed at least through one of the list, and I found the best possible answer, which is 20, 20, 24. And the size of this range is 5, right? So this is going to be my approach. And why is it working the way it is working, right? Because we are taking the minimum element, we are taking the minimum element and comparing it with the maximum element. And at a moment, in our priority queue, there are three elements, right? Or k number of elements. So every k element is from each of the list. Okay, so it means if I take the minimum element from this priority queue and the maximum element from this priority queue, I will get the range, right? I will get the possible range, and all of the elements will be between that range, right? So let's go back a little. Let's say we were at this point, right? When I popped 20, and I made the 20 comma 24, right? So when I was at this point, you can see that the minimum element is 20 and the maximum element is 24, right? But the only number besides them is 22, which is lying in the third list, right? And it is between the range because this is my minimum element, this is my maximum, so it has to be between the range. That's why we are taking the minimum element here and we are taking the maximum element and we are comparing them, right? If the range that it gives me is better than my possible answer. If it is, then I'm going to update the possible answer. Right? It is that simple. So this is my actual approach. Now I'm going to code this. Okay, so let's try to code this question. Okay, so let's see. Okay, so the first thing is that we need to make a vector int. Right, this is my resultant. Now this will derive from 10 to the power minus 10 to the power 5, 10 to the power 5. Right, this is my initial range. Right, and I will take k as nums dot size. Right, nums is my list of list, right? So, or vector of vector. So int max val, and I'm also initializing the maximum here as well. Okay, as my minimum. Now I'll take a priority queue of min heap. Right, so priority queue of vector of int, vector of int, and greater of vector of int. Right. Now after this, I just need to wait. So this is right. Okay. So after this, I need to do for int I equals 0. Right, I equals 0, and I will be less than k plus I. Now I have to move these elements. I have to put the first k elements in my priority queue, right? And I will take 3 elements in my priority queue. I will have 3 elements in my priority queue. So what are the 3 elements? Why am I making the priority queue of vector type first? Okay, so let's see. I will take a mol. This is minimum of the list, right? So the minimum of the list is the 0th element, right? The 0th, because since the lists are sorted already, so the minimum element of the list is the element at the 0th index, right? So nums of I comma 0, right? So it is going through all of the list, taking the 0th element of every list, right? So I'll add vector of int to be added, right? And this will be mol. This 0 is representing the index of the number or index of the number in that list, and this I is representing the list number, right? So this 0th index is representing the minimum in that list, right? The minimum in that vector. The first is representing the index element or index of that element in that list, right? And the second index is representing the index of the list in my nums, right? So this second index is representing the index of my vector in my nums, right? So I also have to update the maximum value, right, at the beginning. So max val comma the minimum of the list, right? So pq dot push to be added. Okay, so after this, first k elements have been added into my list. Now I will run a while loop, and this while loop will run till I provide something with it. And what is the condition when it is going to break? It is going to break when one of the list is completely traveled. Okay, one of the vector is completely traveled. So vector of int, I'll take the minimum value as pq dot top, right? So now after this, I've taken the first value of the minimum value of the priority queue, and I popped the element. After this, I'm going to check if res of 1 minus res of 0, right? This is my current range, or this range, right? This range, it is talking about this range or the current range. If it is greater than my max val minus min val of 0, right? If it is greater than my incoming range, right? If it is greater than my incoming range, it means that this incoming range max val minus min val of 0, if this incoming range is better than this range, then I have to replace this range with my incoming range. Okay, so res of 0 will become my min val of 0, and res of 1 will become my max val, right? After this, I also have to increment the index. So the index of that element in the list is going to be incremented, right? Since I've removed one element, right, I have to also take the next element and put it into my list again. So vector of int, I'll take the current list, which is nums of min val of 0, right? Now after this, if min val of 1 is equals to cl dot size, right? If this is the case, it means that one of the list has been completely traveled, right? It has been completely parsed. So I'm going to break from there. Else I have to update the value of that minimum. So minimum is going to be CL of min val of 1, right? After this, the max val is also going to update itself. So I'm going to check if my maximum value is greater than if my old maximum value is greater than my current value, which is CL of min val of 1, right? If this is the case, then max value is going to be also updated. And after this, I'm going to push that element back into my priority queue. So min val will be pushed. Okay. After this while loop runs, I will have the correct range, right? So after this, I'll just return my resultant from here. Okay, resultant range. So this is my code. Now let's try to run this. Just rejected. Let's see the problem. Okay, so the error was that here, since we are checking for the index, right? We are checking for the um, index of the list in that nums, right? We're checking for the index of the vector in that nums vector, right? So we're going to use 2 instead of 0, right? I've written 0 here. It was 2 actually. So let's run this code. Okay, it is successful. Let's submit this. It is passing all the test cases. So I hope you understand this question. If you don't, I would suggest rewatch the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.